Hello everyone. My name is Ajok Esther, and I am a year two student at Macquarie University, and I do software engineering. So the purpose of this presentation today is to integrate the three elements, the Alison diploma that I did, and the concepts I studied in that diploma, the concepts I learned from that diploma, the concepts we studied earlier on in class, such as data mining and Gardner's multiple intelligences and computational AI philosophies. And finally, I want to incorporate them, like to explain them in the context of my group project, which is a wearable AI maternal monitoring system. So this this project, I want to show how this project is bringing all these things that I have discussed together. And, the idea basically here is to show how all these are working together. So, so AI has evolved a lot over the years, and it has a rich history, starting in the 1940s, where Alan Turing asks that question of can computers think, in his book, which I don't actually remember, but it's in that book where he talked about the Turing experiment, the imitation game. Yeah. And also in the still in the mid 90s, about 1956, where John McCarthy coined the term artificial intelligence at that conference called the Dartmouth Conference. So in the 1980s, there came the expert systems and the AI winters. And the AI winters is where the growth of the whole field slowed a bit. There was a bottleneck there. And it's from that bottleneck of the AI winters that in the 2000, where machine learning and deep learning came, and machine learning and deep learning revived the whole AI field thanks to the big data and the faster hardware. Yes, so the AI field keeps on growing and growing and growing. And in the near future, we expect ethical and more explainable AI, embedded AI, and AI in everyday devices like the wearables. Um, so yeah, I hope that in the future, basically, the future of AI is basically having AI that we can trust and depend on. See, like the way AI right now is everywhere in cars, on our phones. So the future will be, My system is basically supposed to bring AI into already AI is there in the health field, but it's supposed to bring that idea, to embrace it in the maternity field. Yeah, basically that's it. Um, our project uses classification and anomaly detection in a wearable for pregnancy risks, because this wearable basically exists because of this evolution. Because those days in the early AI, the symbolic AI, it couldn't handle medical uncertainty because medical data keeps on changing over and over again. Someone could be fine in the morning and then they get a complication a few hours later. But today, due to deep learning, those deep learning models, and since it can be compressed into a small chip that can be put into a wearable, and there's real-time monitoring on that wearable, it's able to adapt a little to that medical uncertainty. And also data mining plays a big role here because we use classification to identify those pregnancy risks. We cluster the mothers in two groups of high risk, low risk, medium risk, and that determines which kind of attention you give them, because the kind of attention that is given to a high risk patient is not the same that is given to a low risk patient. Yeah. And from Gardner's multiple intelligences, we realize that this wearable has logical mathematical intelligence, because of the algorithms attached. And through all the risk calculations and all that, so yeah, it has mathematical intelligence. Um, it also has linguistic intelligence. Yeah, due to the alert, because the wearable sends alerts to the mother in case a spike in her vitals. Yeah, as long as they go beyond a certain threshold, yeah, it sends her an alert to her that, there's this problem. You could always do such and such a thing. Mm. So yeah, the the wearable, I cannot say the wearable necessarily will be able to predict every possible medical situation, but it will be able to, to bridge that gap, especially in communities where there's limited access to medical services. Yeah, it could be able to bridge that gap and help give first aid. Basically, it's basically a first responder. Yeah, and AI basically formalizes these problems, such as moving from the start state to the goal state. In AI, a problem is basically defined as an initial state, a set of parameters, and then the goal state. The solution is so a sequence of actions that transforms the initial state into the goal. It's basically that transforms the starting point into the destination. Yeah. And the challenge here is the search space. The search space is a set of all possible states and actions. And the frame problem basically shows the difficulty of representing things which change and which do not have to action. But the frame state, though I can explain it in simple terms, is let's say there's a picture, a machine is given a cup. There's a before and after. It's given a cup, a plain cup. Let's say it's a plastic cup. Then it's given that cup a few hours later, and that cup has been painted. So that machine, for human beings, are able to do abstraction. Our brains will abstract. They will take away all. You never think about all the unnecessary things, but for a computer, it has to go back and think about everything, the weight, to remeasure the weight, the height, the diameter, and all that in order to see what has changed. But for human being, you will see and say, oh, only the color changed, and you'll be able to do that. But that's like something a machine cannot do. Yeah. Mm. And in our wearable system, so in our wearable, the mother's current status of health is basically the initial state, and then the goal state is the goal, sorry, is a safe pregnancy, safe delivery, yeah. And then the steps are the interventions, like the adjustments, the medical alerts, and all the exercising plans. So here we apply clustering, which is a determining technique, and then we group the mothers into high risk, medium risk, low risk, because each category will require a different thresholds for vitals, and things like that. So from the gardener's intelligence here, I believe here will require interpersonal intelligence, that is when because basically the system here is a digital caregiver. Basically a digital caregiver, and requires interpersonal intelligence to be able to say, this mother is going through this, so she's high risk. This one is going through this is low risk, and yeah, stuff like that. And then you got to realize that the Chinese room argument here really applies, because you got to realize that the wearable does not necessarily understand that, oh, it's saving lives here, but all it does is just produce meaningful responses, meaningful outputs here to be able to save a mother's life, to be able to monitor a mother's life. Yeah. And then, sorry about that. So basically, such in AI is such is basically how AI explores possibilities, all the different possibilities. And it's basically exploring different paths to find the best solution. And there are different kinds of search. For example, there's an informed search, like bread, sorry, bread first search and depth first search. So these ones basically have zero prior knowledge of the solution. So and this gives them a there's very low chance of actually finding the optimal solution. And then there's informed search. It's basically, yeah, it basically has prior knowledge on the problem, on the subject. And they are like examples are A star and the heuristics. So yeah, these ones basically search with the problem in mind. So it's highly likely that they'll find an optimal solution. So basically, search in AI is exploring different paths to find the best solution because there's some methods like the uninformed search will look everywhere blindly to find the solution, while others like the informed search basically know the problem, so they have the rules, they have the syntax to solve the problem. Yeah. So our wearable basically uses heuristics and to use its heuristics to manage all the risks because it knows the problem, it has knowledge on the problem. So, for example, in an emergency like a seizure, the system will prioritize sending for an ambulance over recommending diet or exercise because, yeah, it knows the problem. And yet, here, if in case we're using bread first search or first search, it basically would look everywhere for the solution. It would basically be it would have to evaluate all the other like the diet plan and all that instead of finding the optimal solution. Um, what is knowledge representation and reasoning? Basically, knowledge representation is how AI stores and reasons with information. So use first order, where first order logic uses predicates and quantifiers and rules. The reasoning, reasoning allows the AI to derive new facts from the existing knowledge. Basically, here AI requires a way to store what it knows, the knowledge it has. And knowledge representation is basically like giving it a language of facts and rules. For example, if a mother there's a pregnant woman and she has high blood pressure, so there she's at risk of eclampsia. So basically, reasoning is how the system will look through all the facts, all those rules that it has, to reach a conclusion that oh yeah, she has high blood pressure, and these are the rules, and this is basically how we can avoid all that in our system, basically, wearable encodes the medical guidelines as actions. And for example, the pregnant woman has high blood pressure and it knows that there's a risk of eclampsia. So it basically knows what to recommend and all that because it actually has the knowledge stored. So yeah, basically it has already classified mothers, has clustered them and knows this mother is high risk. She's having high blood pressure and this is the risk, this is the possible risk. So these are the various ways that we can do to avoid this. Yeah. And here basically the system uses linguistic intelligence to be able to explain the risks to the mother in clear language that she can understand, send her alerts in case her vitals go beyond the threshold, all that. Yeah, that's basically philosophically the simulation argument is where you say, that is the system, does the system really know what it's doing, or it's just simulating the rules, simulating exactly what you showed it to do. Yeah. So basically, our report has rules like that. And at the same time, it learns the patterns from the various health data that it receives and it combines them with the expert knowledge, that it has been embedded in it. So this explains to explain this is important because it's the linguistic intelligence to explain its findings to the mother and tell her, no, the blood pressure is high, do this, to lower it, eat this, do exercise, and all that. Uh, my next slide is inference in first order logic. Basically, here inference in logic means deducing new truths, finding the new truths, and then soundness. Soundness basically ensures that there are only true conclusions derived, and then completeness ensures that all the true conclusions can be, yeah, they can be derived. Then resolution. Resolution rule of inference is a key inference technique that is used. Basically, yeah, inference just means drawing conclusions from what you already know. For example, all humans are mortal beings. And then Albert Einstein is human. So you basically conclude from those two statements, you conclude that, oh, Albert Einstein is a mortal being. So in AI, this is basically done through rules like the resolution. Here, we get where the idea, here the idea is basically to go from the facts you already have, and then you make a logical conclusion. In our wearable, basically our wearable deduces the risks but uses the anomaly detection for all the unexpected things. Because now wearable here, inference rules deduce if high blood pressure and if someone there's high blood pressure, if the mother has high blood pressure and protein in the urine, then it's most likely eclampsia. And then, however, here completeness is quite limited because the system may not be able to capture those rare conditions. That's why it's combined with anomaly detection from the data mining. And so, yeah. And basically, here, this shows logical intelligence. Yeah. Though the frame problem still remains no matter how many rules we keep on encoding, because some situations may not be covered. You cannot say that the system is entirely flexible, it's entirely adaptable. Yeah. And then next slide is reasoning under uncertainty. Healthcare, basically the whole field of healthcare is uncertainty. So here was the probability theory models those uncertain events, whereas the bias rule that updates the beliefs with the new evidence and it binds all the probability with utility to make rational choices. Because nothing in life is certain, and a mother might present some symptoms that do not necessarily guarantee that she has the disease. For example, she might have high blood pressure and a lot of protein in her urine, but it does not necessarily guarantee that she has eclampsia. So that's why AI uses probability to say how likely something is. So the bias really helps the system to update its predictions as the new evidence comes in. And basically, decision theory helps us to choose the best action, considering both the probability and also the outcome. In our project, the way basically uses the Bayesian reasoning. For example, your mother has high blood, she has pressure, she has headache, sorry. So there, the probability of her having eclampsia is higher. And then the decision theory basically helps decide whether to notify the mother or notify her caregiver. Because there's that in case in case of an emergency, her next of kin or her emergency contact is informed, and then the ambulance is called, and her gynecologist is also informed to be ready. Because these are essentially determining probability models. Yeah. And this also reflects on intrapersonal intelligence because it's basically tailoring risk calculations for every individual because no two mothers are the same. So here the system basically tailors every mother's risk calculation according to whoever she is. And philosophically, the Turing test still reminds us that this system can be trusted like a human advisor, even if it's a machine. So just keep encouraging the mothers that, oh, you do to not ignore the alerts just because it's a machine. Yeah. The next module was planning. And basically, planning is a process of creating sequence of actions to achieve a goal. Shapes is basically a common representation and situation calculus modules, changing states with actions and affluence. Basically, planning is about arranging actions in good order. And AI just doesn't randomly act, It plans all the steps it has to take to achieve that goal that it wants to make. For example, if the goal is, let's say, to make bread, it knows all the steps you have to mix them the ingredients to make the dough, because the order matters in order for the goal to be achieved. Now wearable, basically, the wearable plans both the daily routines and the emergency responses, because daily plans are basically planning meals, exercise, rest. The emergency plans are, let's say a seizure has been detected, it's basically alert the physician, alert her emergency contact, call the ambulance. So it makes the plan even when something has not happened yet, because that plan is what actually helps in that time. Because from data mining, here we use sequential pattern mining, sorry, helps us to discover those common sequences that lead to the complications. Let's say it will know when her blood pressure gets high, the protein in her urine goes higher, stuff like that. Should start preparing to call the ambulance or to call her, to alert her that there's a high risk of eclampsia, something like that. This ties to body bodily intelligence, kinesthetic intelligence, in supporting physical activities, yeah, and all that. Yeah, rugby. Philosophically, we can say the system is a weak AI, because I don't think it doesn't think like a human being. It just imitates a human being. It follows a set of rules in order to reach that. It makes the rules, make the plan that the system is able to follow. Yeah. And then the next slide is planning and decision making. Planning under uncertainty, in periods of uncertainty, is modeled with Markov's decision processes. And that MDP basically defines the states, actions, and all the rewards. And then policy iteration and value iteration help the computer help the computer to compute the optimal policy. Then decision networks add the probabilities and the utilities. Yeah, basically, sometimes planning happens, okay, actually, most times planning happens under uncertainty. And that's where this MDP comes in, because it helps the system to think in terms of states, actions, and what. Because the system looks at all the possible choices and tries to, and picks the one with the best outcome. Yeah. So in relation to our wearable, the state, basically the state is the mother's current health. The actions are those interventions, and the reward is her safety, safe delivery. Basically, her being alive is the reward. So the wearables policy basically decides whether to simply notify the mother or escalate to call the ambulance. So the classification trees from data mining approximate these policies. Because this, and also according to the Gardner's theory of intelligence, this reflects interpersonal intelligence, where, yeah, basically communicating the alerts effectively, yeah, and all that. And then, yeah, you also got to realize that We cannot say that the wearable knows exactly what it's doing. It knows how to do it, but it does not know what it's doing. I should say it like that. It's sending an alert. It is following rules that, in case this happens, send her this alert, you know, basically coming up with the best possible solution among the solutions it already has. Yeah. The next, yeah, this is the last module, is machine learning. Basically, machine learning allows the system to improve from the data. It allows the system to learn from the data. Yeah, this can divide into three. We have supervised learning. Supervised learning basically uses labeled data, and unsupervised learning finds patterns, and then the reinforcement learning adapts through user feedback. Basically, machine learning is about teaching the computers to learn from the data that they've been provided. In supervised learning, you give it examples with the answers. Then in unsupervised learning, you just give it the data and then to look for the hidden patterns within the data. In reinforcement learning, sorry, yeah, it learns through basically trial and error. It gives you an answer, you give it feedback, say, no, this is wrong, and then to learn from that. In context to wearable, sorry, it we basically apply the three kinds of learning, because supervised learning basically trains it on the pregnancy outcome data sets. You show it exactly, you show it the risks, the outcome, the problems, what would happen after this, you show it all that. And supervised learning basically to cluster the women into groups by risk, low risk, high risk. Then it will look through, and yeah, it will look through. You give it the data set, sorry, to look through and see which of the women, what risk they are, and classify them, cluster them according to their level of risk. And then reinforcement learning is basically through feedback. Let's say if the system makes a mistake, let's the hospital, and yet the mother is not in any danger. You could always give it feedback and say, she was not in any danger because of this, this, and this. So yeah, that would be feedback. And this reflects highly on logical intelligence. In logical intelligence. Yeah, because yeah, basically logical intelligence. So that is all I had to say. In conclusion, this project basically shows how the AI foundations integrate with the theory and the practical of healthcare applications. Because it shows how, the concepts from the Alison course I talked about integrate with data mining and Gardner's multiple intelligences and computational AI philosophies. Basically, how wearable turns all these concepts into a practical engineering solution, predicting complications, planning care, and yeah, basically saving lives. I think I can show you the the course. Let me share it. Certificates. This is the diploma. Yeah. So yeah, thank you for listening. And that's all I had to say.